Thank you very much. So, like they said, I'm Jared Forsyth. On Twitter, I am at Jared Forsyth. And if you want to follow along with these slides or look back at something later, the link is at the bottom. I am also the co-host of ReasonTown, a podcast about the Reason language. So if at the end of this you're really excited about Reason and want to learn more, check that out. We've got a bunch of beginner-friendly episodes and also some more advanced topics. So what we're going to talk about today is first, why Reason? Why should you be interested in Reason, especially in the context of React applications? And then I'll give you a little bit of a view of what it looks like, what the syntax looks like, how to use it with React. And then finally, I'll cover how you can get started. Really quick ways for you to dig into Reason, see what it feels like, and then learn more. But before I start, I should ask, who here likes types? OK. Y'all are like, web development with types is the best thing. Everybody who didn't raise their hands, I gave a talk last year at ReactiveConf that is titled "Type Systems Will Make You a Better JavaScript Developer." And there I lay out my reasons for why I think I don't want to do JavaScript without types anymore. And if you are convinced but your boss isn't or your coworkers aren't, you can show them this video. Now, to define some terms, you might be asking, what in the world is Reason, right? Reason is a new syntax and tool chain for OCaml, which for many of you brings up a new question: what is OCaml? OCaml is one of those languages that you'll find on blog posts that are like 5 languages that will change the way you think about programming. Right? On there is Haskell and probably a Lisp, maybe Clojure, and OCaml comes up a lot as well. It's one of those kind of grandparent languages that a lot of the new languages that are coming out are inspired by. So Rust, heavily inspired by OCaml, Swift as well. But it's been mostly relegated to academia with a couple of key industry players, but certainly not the kind of community development that you'd find in something like Python, which is also decades old. And I'm also going to mention BuckleScript, where BuckleScript is a new compiler that will take OCaml or Reason code and turn it into performant, readable JavaScript. And it's also very fast as a compiler as well. So first, why Reason, right? And if you were paying attention during David Kopal's lightning talk yesterday, you already know the answer to this, right? Reason is the best way to write React. And the reasons for this are that React was originally developed not in JavaScript, but in standard ML, which is a cousin language to OCaml. And so core principles of React, like immutability, like defining prop types, feel a little foreign in JavaScript, but are right at home in Reason and Reason React. Another reason, a question that people ask me is, well, I've already got types in my JavaScript, right? Lots of you raised your hands using TypeScript or Flow. So why would I care about Reason? And I like to answer this by using an analogy. Here are 2 sea-going vessels, right? On the left is USS JavaScript, and then there's the USS OCaml. And right away, you can see there are some differences, right? JavaScript looks a lot more fun. It's got a lot more going on, right? There's some fresh pie in the window, if you can see that, and a ping pong table, fireworks. Whereas OCaml looks quite drab by comparison. There's not as much going on. It's gray. But you'll notice in this picture, you can't see the most important part of the boat, which is the hull. And now you can see there's some important differences here as well. JavaScript, for all of the fun that it is, has some holes in it. Maybe this is, undefined is not a function. Or, this was a string you're trying to get the name attribute off of it that doesn't exist. And especially when you're working in a large project or you've got lots of developers touching the same code, these can come to bite you. One of the most frustrating things that I've found when working in large JavaScript projects is I get an error that's like, undefined is not a function. And I have no idea where it came from, right? I know what was undefined, but how did it become undefined? And I have to trace it back, usually with breakpoints and console logs all over the place, to try and figure out. And often it was many, many call stacks away, where it's like, oh, I made a wrong assumption about the shape of this object or the type of this value. Whereas OCaml, with built-in, from the ground up, type safety, just rules that out. Now, the fact that JavaScript has holes in it doesn't mean it's going to sync, right? We're shipping JavaScript applications. They work. And so if water gets in the boat, you just pump it out. In this case, maybe this is unit tests, right? If we get 100% coverage, then we'll know that our code doesn't have any bugs. Or at least it doesn't have bugs that we wrote tests for. But there are more holes than that. So maybe you add in strict linting. You add in strict code review to try and guard yourself from all of the footguns that are honestly included in JavaScript. And once you add all these things on top of it, it becomes less fun, right? You can't even see the ping pong table anymore. Now, Flow and TypeScript take a different approach, right? It's not bailing water out. Let's patch up the holes, right? This is fine. We will add on a type system that knows how to prevent you from using undefined as a function and things like that. But it can't cover all the holes. And these are evolving technologies that each month or every couple of months, they make changes to the type system, try and make it more robust. And the other issue is they have to work with the existing JavaScript, right? So you're patching on safety onto a fundamentally unsafe structure. And my thesis is that it's far easier to start with a foundation that is solid and sound and add on a little bit of party, add on a little bit of ease of use, community development, that kind of thing, then to try and start from an unsafe place and make it safe. To present this in a little bit more boring way, here's a chart for you where JavaScript is much more easy to use, but very low on the safety scale. And Flow and TypeScript try and bring it more towards safety. Whereas OCaml starts out much safer, less easy to use, and Reason is trying to make it more easy to use, easy to get started, easy to integrate with JavaScript, that kind of thing. Now, so kind of TLDR of this is TypeScript and Flow, they just don't have the same kind of safety guarantees. But definitely they're better than just using JavaScript by itself. The other question people ask me is, well, how about Elm? Right? Why should I be interested in Reason and not Elm? And if you're already using Elm, I say, power to you. Like, Elm is really awesome. There has some really excellent error messages, really thoughtful leadership by Evan Zaplicki, and I'm just impressed with everything they do. So if you're already using Elm, I don't want to dissuade you. Now, if you are currently using TypeScript or Flow or JavaScript and are asking which of these two should I pick, right? What are the differences? Here's kind of some of the key differences. The most obvious one when you look at some code is the syntax, right? And some people will say, it doesn't matter, but it's I see it as one fewer thing for you to try and, one fewer hurdle if you're trying to get started. So Reason has put a lot of effort into being very JavaScript-like, whereas Elm is written in Haskell, inspired by Haskell syntax in many ways. And then the other differences mostly boil down to a difference in philosophy. Elm takes the stance of safety and purity overall. If there's something where it's like, oh, it would be easier if we did this, but a little bit less safe, Elm says, no, it's not worth it. And I know people where they love that, that viewpoint. Reason, on the other hand, says, we want more ease of use, even if it means a little bit less safety. A good example of this is JavaScript interop, right? If you are writing an Elm app and you have some existing JavaScript that you want to use, there's kind of a lot of work required to get that integrated, right? You have to set up a message passing protocol. You can't call JavaScript functions synchronously. And so, of course, you can't use like a React component very easily from your Elm UI. Reason, on the other hand, wants to make it as easy as possible for you to take your existing JavaScript React app and add in Reason a little bit at a time. Get a little bit of type safety at a time. And so if, for example, the JavaScript function is misbehaving, that could still crash your app. That could cause problems, whereas in Elm, because you do the extra legwork to isolate things, you're more protected from the unsafety of JavaScript. Another example of this is mutation, right? In Elm, immutability is the only way. In Reason, immutability is the default. But there are some algorithms you'll find, maybe a performance-sensitive area, where really the only way to do it performantly is to use mutation, and you can reach for that. So in Elm, you might find yourself needing to go out to JavaScript, write the core algorithm in JavaScript, and then do message passing. Whereas in Reason, because it's a little bit less safe, you can stay within Reason. Now, I also want to say, why not Reason, right? I'm not some starry-eyed evangelist. There are definitely reasons not to use Reason. The first one being that the community is still small. Only started up a couple years ago, still growing, and that can be a downside, especially if you have a large team. The second reason is tied to it. There are fewer tutorials and documentation, that kind of thing, that come along with a community. And so if you have a team of 15 developers where you want them all to onboard onto this new language, this can be a sticking point. And the third reason is just that change is hard, right? Don't underestimate the cost of taking a production JavaScript app and moving it to a different language. If it's Elm, if it's Reason, if it's Clojure, whatever. It's also hard to onboard people if you have a large team to get them all to move over. But I do think that Reason is ready for production. There are many companies using it in production today, especially if you have a smaller team where everyone is excited about functional programming and types and is ready to get over the initial hurdle. The productivity gains after that, I think, are impressive. So now what does it look like? Hopefully you're interested. You're a little excited about learning about Reason. Here's the basic syntax. And like I said, it's trying to be very much like JavaScript. This is a function declaration. So it looks like an arrow function and doing a little math in there. The difference you'll notice is there's no return statement. In Reason, similar to Clojure and Rust and some other more functional languages, just about everything is an expression. So this block has a return value, and it's just the value of the last thing in the block. This also gets used here in a switch block, where the value of the switch block is just the value of whatever case was matched. And so we can assign that to a variable. Another cool thing that Reason has that I take advantage of a lot is named arguments, which if you've used Python or Swift, you'll be familiar with. And named arguments can be optional, and they can have default values, which comes in handy a lot. We also have JSX. As a language that wants first-class React support, of course, we need JSX. And it's very similar to JavaScript. It's JSX. So here's an event handler, and creating, making a custom component looks the same. Here we can take advantage of the fact that an if block is an expression, right? It has a value. And so you don't need to have nested ternaries like you might in JavaScript's JSX. You can just have an if block, and it works fine. Another nice feature of Reason's JSX is the property punning. If you have a property that doesn't have a value, instead of being that name equals true, it's, in this case, data equals data, which comes in handy when you're passing a lot of props around. So let's actually look at React and what it looks like to make a React component in Reason. Here's the basic stateless component. And we're introducing some new syntax here. So a module is just a way to encapsulate some functionality. Kind of like an embedded file. All files are modules, and you can have modules in modules. And this is the way that Reason's JSX knows about custom components. So we define a stateless component, and we create a render function for it. And the props are actually just arguments to the make function that we can then use in render. And we'll see in the JSX transform that in JavaScript, if you're familiar with the outputted JavaScript, it becomes React.createElement, and then myComponent, and then a props object. Whereas in Reason, it becomes Reason React.createElement, but then myComponent.make. So it's calling that make function that we had before with the props that we passed in as arguments. So hopefully that makes sense. The make function gets called, and that's how that's set up. Now, getting to local state, this is one of the places that Reason React really shines, where it has innovated on the models that React had, brought in a little bit of Redux, but still true to the React ideas. Here we have a counter component that I'm creating, and we define an action type at the top. And we have a reduce function that if you've used Redux at all, taking an action and state, and then creating a new state from that action and updating the state will be very familiar to you. And then down in the render function in an event callback, we can call self.send, which is the same as Redux's dispatch. And what you get here is basically the organizational benefits of Redux, where you have all of your state transitions well defined, you have all of the actions that might happen in the same place, but you still get component local state. One of the difficulties when using Redux, especially in a large application, is that components are now dependent on the global state. You can't compose them as well. You can't reuse them as well because of the global nature of Redux. With this, you get the best of both worlds. And, of course, the hooks announcement last weekend has a use reducer that is inspired by Reason React. So they're getting jealous and bringing some of that in. So, of course, I had to do a hooks demo, right? This is from the announcement blog post that is using the use state hook. And if hooks get accepted, right, it's still an RFC, then it will make Reason React a lot more similar, right? Because it's just embracing functional ideas. The Reason looks almost exactly the same. Because you can call the hooks.use state, you can get the current state and the setter function. And it will actually make the differences between using React in JavaScript and React in Reason much, much fewer. So how do you get started? In the past couple of months, there have been a couple of really neat innovations in online services to help you try out Reason. One of our community members created sketch.sh, which you can look up. And if you're familiar with IPython notebooks or Jupyter notebooks, it's very much in the same line. You can have markdown nodes, and you can have code that gets evaluated inline. It's a REPL, essentially. And speaking of REPLs, REPL.it is an excellent service that has a staggering number of programming languages supported. And they just recently added support for Reason React. So you can get up and running there as well. And Code Sandbox also recently added support for Reason React. So whichever you're used to using, you can keep using that and try out Reason. But what if you want Reason on your own computer, right? You want to actually dig in. Create React App has a Reason preset that you can use, and it will create a project for you. Another thing that we put a lot of emphasis on, like I said before, is using Reason integrating it into an existing JavaScript app. All right, so I'm going to go through a little bit what it looks like to get that done. First, you need to add BS platform. That stands for Buckle Script platform, if you're wondering. And there's a config file that tells it kind of how you want to compile the reason into JavaScript and where you want to put it. And once you run these commands, it will, for every .re file in your source directory, it will create a .js file right next to it. So in your, say we've got this reason component that we're building, and we want to use it from JavaScript, right? So at the top, we've got our module that has a make function in it, like I demoed earlier. And then we need to do a little bit of wrapping to show, OK, this is how you use JavaScript props, translate between the two languages just a little bit. Because JavaScript props are an object, and you need to pull out, in this case, the name and the age, and then pass them to the make function as arguments. And then from JavaScript, it couldn't be easier, right? It's literally just grabbing my component from the JavaScript file that was generated in the same directory and using it as normal. And then the other way around is even simpler. So first, we declare that there's an external, not in reason value that we want to use. It's in this someComponent.js, and it's of type reasonReact.React class. And we create a make function that takes in the props as arguments again, and then creates a JavaScript object to pass into the underlying JavaScript React component. So what's next? And actually, I've got a little bit extra time, so I've got some extra content here. You might be wondering, if I'm using Flow and TypeScript already in my JavaScript, and then I add in reason, I want to make sure I'm not losing type safety by adding in, this new type-safe language, right? For example, from the using a reason component in JavaScript, what if I misspelled a property name? Currently, this wouldn't be caught because the JavaScript object that reason sees, it doesn't know what the type is, right? And then on the other side, in your TypeScript file, it doesn't know what the type of the reason component is. It can't check for you. It's essentially opaque to it. So there's and going the other direction also has potential errors in it, right? If you have, in your reason wrapper file, you're not using the right types that TypeScript expects in its component. And there's a project that was released recently, still in development, but it's called GenType. And it will basically allow you to take for example, a reason React component, you add this decorator to it, and then it will create a TypeScript file for you that has the prop types there correctly, such that when you use it from TypeScript, it will get everything right. It also does the wrapping for you so that you aren't using the JavaScript object incorrectly by mistake. So this props declaration is auto-generated, and this make call is also auto-generated. And it goes the other way as well, right? So you can do a gen type on your import when you're using, for example, a TypeScript React component from your reason, and it will generate the interface for you to make sure that all the types line up. A couple more things that I like about using React in Reason. Here's the render prop pattern, where is been popular for 6 months at least, so maybe you've heard of it. And this is where you want to do a higher order component, but it's just a different way of doing it. And the way to do it is to have, again, a render prop, and you call the render prop with, for example, the data that you've got. And it looks basically the same as in JavaScript. There's also the proxy component pattern where in JavaScript, if you've got some component that you want to pre-fill a prop for, say some other component, it takes a lot of props, and you just want to pre-fill some prop and then have a component where you don't need to pass that in. Right? This happens sometimes. And in Reason, we get to take advantage of currying, where every argument to a function can be provided separately. Here's a basic example of currying with simple math functions, where we have add two numbers, and it takes two arguments. We can pass the first one, and then it will return a function that's waiting for the second one. And this all makes sense once we get to the way that Reason does make functions, right? Where it's just a function waiting for some arguments, so we can pre-fill one of the arguments to the make function and return a new component that is essentially waiting for all of the rest of the props. And one of the things that I'm most excited about in Reason is the ability to compile to multiple platforms. Right? OCaml initially wasn't meant for the web at all, right? It compiles to native or to bytecode. And so the OCaml community has created cross-compilers that will take in Reason or OCaml code and output native iOS binary or native Android binary that you can then use from Objective-C or Swift or Java, in addition to being able to compile your Reason code to JavaScript. And I did a little proof of concept of this earlier at the beginning of the year. I made a game for phones, and it's the same code base shipped on the web and on the App Store and on the Google Play Store, just to try it out. And it all worked, 100% code reuse. But the next frontier, the thing that I'm really excited about, especially with React, is having a React Native that's really native, right? Not just we're using React, but it's in a JavaScript VM, and so it's slow sometimes, and you've got to talk across the bridge, which can get blocked. If we were able to have the same Reason React code that you're writing, but compiled to actually native, it unlocks a world of possibilities. Thank you very much.